Alright, hi guys, so in this video we're going to be continuing on our indices, except we're going to be doing some practice problems instead. So the thing we're going to be looking at are some more AddMath style questions. So we'll be looking at simultaneous equations with indices, U substitution in indices, and a little bit more with that. We'll also be using a lot of the Indices Laws in order to make it work. So let's get started. So we have an equation here saying 4 to the power of x minus 6 times 2 to the power of x plus 8 is equal to 0. First thing we can notice is that this can be made to the same power as this. We can actually write 4 to the power of x as 2 to the power of 2x as 2 to the power of 2 is 4. And that can be replaced here with that. Second thing we can notice is that it's equal to 0. This suggests a very much quadratic-like structure. So let's just substitute this into the 4 to the power of x section. Let me erase that now because it looks a bit difficult. 2 to the power of 2x minus 6 times 2 to the power of x plus 8 is equal to 0. Now, what we can notice is that this has a very much quadratic-like structure, and we can actually replace u with, 2 to the power of x with u. So let's let 2 to the power of x be u. And now, this is because it's a quadratic-like structure, and we can see that it's to the power of 2x. 2 to the power of 2x is the same as 2 to the power of x times 2 to the power of x, because you just add the indices. Which means that, in other words, we're multiplying u by itself because we've substituted it in here. So it's u times u, which is u squared. Minus, and then this is easy, just substitute it in here, so it'd be 6u plus 8 is equal to 0. Whenever you see it ending with 0, it suggests that it has a quadratic-like structure, and in that case, you should replace a common term with a value of u to get the quadratic. Now we have an easy quadratic that's easy to just factor. That can just become u minus 4, u minus 2 equals 0. So u is equal to 4 or 2, but we're not done here. Now we have to make 2 to the power of x equal u. So let's say 2 to the power of x is equal to 4. Then x is definitely equal to 2, because 2 to the power of 2 is 4. On the other side, let's see if 2 to the power of x is equal to 2. Then x is equal to 1, because 2 to the power of 1 is 2. So our values of x are 1 and 2. That will make this correct, and we can check it. Let's say 1 is substituted in here. Well, 4 to the power of 1 is just 4, minus 6 times 2, which is 4 minus 12, which is negative 8 plus 8, and it's equal to 0. And I'm sure the same thing would happen for the next problem, for the next solution, sorry. So essentially just use u substitution when you have a common term like that. And also we can obviously write it like this to easily substitute u and make that u squared. So now on to the next problem. Alright, so let's look at this problem here. So 4 to the power of x plus 1 times 8 to the power of x is equal to 1 over 4. First thing we should do is convert everything to an indices with the common base. So 4 to the power of x plus 1 can be expressed more simply, because 4 to the power of 4 is equal to just 2 squared. So we can make this 2 to the power of 2 and then multiply it by the indices at the top to make the same thing. Because 2 is the simplest base, and it's actually a common base throughout. Because when you multiply by 8 to the power of x, 8 to the power of x can just be written as 2 to the power of 3x, because 2 to the power of 3 is equal to 8. And that can equal, well, 1 over 4 can be written as 4 to the power of negative 1, which can in turn be written as 2 to the power of negative 2. So this is equal to 2 to the power of negative 2. Now we can simplify this part here to make it 2 to the power of 2x plus 2 times 2 to the power of 3x, which is equal to 2 to the power of negative 2. And we can use indices laws to add up the exponents here, because there's a multiplication sign, which will make it 2 to the power of 5x plus 2 is equal to 2 to the power of negative 2. Now we just need to actually just solve for 5x plus 2 is equal to negative 2, because we need to equate the exponents, which means that 5x is equal to negative 4. So x is equal to negative 4 over 5. And that's our final answer. And we can check it by putting it in here. So we can actually use a calculator to ensure that we've done it correctly, because it's not using a whole number. So 4 to the power of negative 4 over 5 plus 1. Then we multiply that by 8 to the power of negative 4 over 5. And we see the answer. It gives us 0.25, which is the same as 1 over 4. So therefore, this is the correct answer. For our next problem, let's look at this. So solve the equation 9 to the power of 5x divided by 27 to the power of x minus 2 is equal to 243. So this is very much like our last one in that we have to make everything to the same power. Well, to the same base, sorry. So 9 to the power of 5x can be written as 3 to the power of 10x, because it's 3 to the power of 2 times 5x, which is 3 to the power of 10x, which is divided by, and then 27 is also known as 3 to the power of 3. So that's 3 to the power of 3 times x minus 2 in brackets. And 243 is the same as 3 to the power of 5. So we have that. Now, we can rewrite it, we can simplify it further as 3 to the power of 10x is equal to 3 to the power of 3x minus 6, which is equal to 3 to the power of 5. Now using laws of indices, so we're dividing here, so that means that the exponents are subtracted from each other. So that's 3 to the power of 7x plus 6, actually, because if you look at it over here, it would be 10x minus, and then in brackets, 3x minus 6, which is equal to 10x minus 3x plus 6. Don't make that mistake. It's a very common one that I almost just made, which is equal to 3 to the power of 5. Now we've got the same exponents here. No, the same base here, sorry. So now we have to equate the exponents. So 7x plus 6 is equal to 5. 7x is equal to negative 1. So x is equal to negative 1 over 7, which is our final answer. Now let's move on to our next problem, and possibly our last one. Okay guys, so this is the last problem. It's probably the hardest one out of the lot. And it works very similarly to some of the other concepts we've learned, except that it requires simultaneous equations knowledge, which is also a little bit more difficult in this instance. So if you haven't covered simultaneous equations, do check out the video on them, which will likely give you an idea of how they work. But for those of you who already know how they work, then let's get started. So the first thing is, in each of the equations, convert them to a like base, because then that allows you to get rid of the base and therefore make a linear set of equations. So a to the power of p plus 1, let's split it up into equation 1 and equation 2 first. Equation 1, and I'm just gonna write 2 here, but you know it's equation 2. So let's split it up first. Let's draw a line here. Okay, so a to the power of p plus 1 can be written as 2 to the power of 3 times p plus 1, divided by 2 to the power of 2q, because 4q to the power of q can be written as 2 to the power of 2q, which is equal to 2 to the power of 11. So now we've all got the same base here. It's a similar base here, so we can actually easily equate this to make a linear system of equations. Now let's do equation 2. That can be written as, so everything here can be written to the base 3. So 3 to the power of 2p plus 5 is divided by, and then 27 can be written as 3 to the power of 3. So 3 to the power of 3 times 1 over 3 is just 3. So this can be written as 3. And let's just write to the power of 1. So it's easier to do our indices rules and everything. Which is equal to, and then 9 to the power of 3q can be written as 3 to the power of 6q. Okay, now we can remove the line because we've evaluated them in such a way that we can actually just make a linear set of equations. So for equation 1, it can be written as 2 to the power of 3p plus 3 over 2 to the power of 2q, which is equal to 2 to the power of 11. Over here in the second equation, we can already start making like a system of equations. So 2p plus 5 minus 1, as per the laws of indices, is equal to 3 to the power of 6q. Oh, and sorry, I meant to make this 3 to the power of 2p plus 5 minus 1. Then, let's scroll down a bit. This can be simplified. Equation 1 can be simplified to 2 to the power of 3p plus 3 minus 2q is equal to, is equal to 2 to the power of 11. Which we can simplify further down to 2 to the power of 3p. Oh no, we can actually just make it a linear set of equations. We can just get rid of the bases because they're on the same side. So 3p minus 2q. And then let's just bring the 3 to this side like early because then it makes it easier. So while it would be plus 3 on this side, we're subtract 3 from each side to make it 8. 11 minus 3 is 8. So this is our first linear equation. Over here, this becomes 3 to the power of 2p plus 4 is equal to 3 to the power of 6q, which means that 2p minus 6q is equal to negative 4. So that's our second set of equations. Now, we only need to equate them. So let's just write them on top of each other to make it easy. So 3p minus 2q is equal to 8. 2p minus 6q is equal to negative 4. Now let's first identify a term we can use to so let's use elimination method, because in this case we can actually see that 2q and 6q can easily be made the same if we just multiply this equation by 3, which would become 9p minus 6q is equal to, and then 3 times 8 is 24. Let's write this equation below. 2p minus 6q is equal to negative 4. Now to eliminate the q, we would need to we need to subtract each side. So we'd have 9p minus 2p, which is 7p. And then negative 6q minus 6q is just negative 6q plus 6q, which is just 0. And then 24 minus 4 is 28, because it's 24 plus 4, basically. So p is 28 over 7, which is just 4. Now let's find our value of q. So when p is 4, let's use this equation here. So let's do it here. 9p, well, we can actually substitute p in. So 9 times 4 minus 6q is equal to 24. So 36 minus 6q is equal to 24, which means that 6q is equal to 12 and q is equal to 2. So as per our simultaneous equations, q equals 2 and p equals 4, and that's the final answer. So we've gone through many different practice questions, and I think now it's your turn to put it to practice. So I'll link some worksheets below in which you can practice some of your indices knowledge in more unfamiliar situations. Overall, these last few questions I just covered were more AddMath style questions, but I still recommend people in CIM also take a look at it. However, I will label it as AddMath because most of these are from AddMath papers.